got through Mod 7. We're going to start Mod 8 by looking at angles. This is a very typical angle and a pretty easy one. Okay, but before we talk about it, I want you to understand that an angle is made up by rotation. So if I take these two rulers, okay, and I have them both set here, and I rotate them, that rotation is measured in degrees. And we're going to talk more about how many degrees that really is in that rotation, in different kinds of rotations. So first we'll start by this very simple angle, and we'll notice that it has 3 letters on it. An angle is formed by 2 rays, and I want to talk about a ray. A ray is actually part of a line. Now, let me define line for you. A line actually can't be defined. It actually can only be described. A line is something that has infinite number of points that goes on in both directions without end. A ray, on the other hand, is part of a line that only goes off in one direction. So this is the vertex or the end point. This is called the end point of the ray, and it goes off in only one direction. So notice that this angle is made up by 2 rays, ray AC and ray AB. And when you name a ray, you always start with the end point. So ray AC, AB, and that's also the sides of the angle. So the sides of the angles are named by only 2 letters, which is the ray it's comprised of. Now notice the angle itself is this rotation. So it's this right here that's the angle itself, which I had a little 1 in there. Okay? There's a couple of different ways you can name an angle. One way is to name it by 3 letters. You can name this angle BAC, and by the way, you can use this as a symbol for angle or this as a symbol for angle. I have to tell you, when I was growing up, I know when the dinosaurs were around, we only used this symbol. I don't really like this symbol because to me it looks like an is less than symbol. So you're probably going to see me use this more than this one, but they are both possible. So I'm going to just write using the symbol of my choice. I'm going to use this and name this BAC. Let's talk about this a little bit. This is angle BAC. An angle is made up of 2 rays that share a common endpoint. Here's its common endpoint. This endpoint is called the vertex. And whenever you name an angle by 3 letters, the vertex must be in the middle, which if you think about it makes common sense, because BAC, I can follow it like this, or CAB, I never have to pick up my finger because they're all connected. CAB, BAC, that's the same angle. Again, vertex in the middle. It makes no sense to say BCA because there is no connection between B and C, so I can't say BCA because there is no BC. So therefore, there's one way to write an angle with a vertex in the middle. Of course, I can write it two different ways, but really this is one way because this is with the vertex, 3 letters with the vertex in the middle. I'm not going to write the other ways out because they're in your workbook, but I want to talk about them. Another way is to just use the vertex itself. But the only time we can use just the vertex itself is when there's only one angle there. If I tell you angle A, you know exactly what I mean. I mean that angle right there. So that's a second way. A third way is sometimes we either put a little letter or a little number inside the angle itself. So I'm calling this angle 1. So those are the 3 ways. One way is the 3 letters with the vertex in the middle. Another way is just the vertex itself, but remember, only when there's one angle there. And the third way is to either have a little number or a little letter inside the angle itself. So those are the 3 ways you can show an angle, name an angle. So let's take a look at the next problem. Okay, taking a look at this next problem, we want to name all the angles in this diagram, and we want to list other ways to name this angle X. And this angle X is right here, this rotation. So we want other ways besides X to name that. So take a look at your workbook and try this problem, and then start the video again when you're ready. Okay, so let's name all the angles in a diagram. I like to kind of be a little anal, so I'm going to start from here and just go around so I don't miss any. So I'm going to look here, AEB. Okay, that's this rotation right here, AEB. That's this angle right here, AEB. Okay, so angle, and of course that's my favorite symbol, AEB. Of course, if you write BEA, that's the same angle. Okay, now I'm going to stay with A. Okay, I'm going to go AEC. That's this whole rotation right here. Okay, AEC, AEC. And then I'm going to stay with A again. See what I can do. AED. That's a straight angle. AED. Let me show you kind of what that's like doing. That's like having, think of my finger as the vertex here. That's like coming around and going right there. That's a straight angle, so that's the rotation there. If we think about that, that's 180 degrees. Okay? At any rate, let's look at some other angles. I think we're done with A. Let's go to B. BEC. That's this angle right in here. BEC. Okay? And then angle BED. Angle bed. Okay? BED. I think we're done with B, right? Nowhere else to go. Now, let's go to C. CED. Angle CED. Now, if I start going backwards, watch what happens. If I go to D, then I could go DEC, but DEC is this angle we just did. DEC is this angle right here. And if I go CEB, well, CEB is this angle right here. So if we just go left to right, we can get all the angles. So those are all the angles in that diagram. Okay? Now let's take a look at angle X. So this is all the angles in the diagram. Now this is the other ways to name angle X. I'll put this right here. Angle X. Obviously that's one way, angle X. Another way is angle CED. Okay, and if we wanted to put a number in there, we could name it, but that's the name of that angle. I cannot call it angle E. The reason I can't call this angle E is because there are many angles at angle E. Look, there's this one, and this one, and this one. Okay, so there's all these other angles at angle E, so I can't call it angle E, so I can't name it with one letter. So those are all the different ways, all the different angles in a diagram, and the different ways we can name angle X. Okay, this is the next problem in your workbook, and I would like you to go and write a description for each angle. I don't want you to use any geometric names that you might know. Just write a description so that if you described it to the whole class, we would be able to pick out which angle you're talking about. So don't use any technical geometric terms. Just write a description for those, okay? And click back when you're ready. Now, you might have wondered why I even asked you to do that. I asked you to do that because you need to understand that there is a reason why we teach you some of the things we teach you. Like you might say, well, you already talked about this. This is called a straight angle. And you'd be correct, but I didn't ask you for the name. I asked you for a description. So let's talk a little bit about the descriptions. Well, you might say here, well, this one is 180 degrees, because we already talked about that. And you would be right. It's 180 degrees, that angle. Exactly. You might look at this one and say, and it's better in your workbook than it is here, this is supposed to be straight up and down, and that's a 90-degree angle, and you'd be correct with that, okay? And usually you see that little square or that little corner to suggest 90 degrees. Here, you might notice, and you might not, but you might notice a good way to describe this angle would be that if I notice, if we compare angles to 90 degrees, there would be your 90 degrees, so this is more than a 90-degree rotation. So what happened here, if I go back to my handy-dandy rulers, okay, here's your 90 degrees, but this went a little bit further, so it's a bigger rotation than 90 degrees. So we could say that, more than 90 degrees. If you had a little protractor, you could measure that. I know that makes you happy. All right, and then this one, if you think about that same thing about your rotation, if 90 degrees is right here, then that's less than 90 degrees. So again, if you compare them to 90 degrees, it makes it easy to describe them. Okay? So here's your 90-degree rotation, and that's less than 90 degrees. Well, I think now it's time to take a look at that. We have names for these because you don't want to go describing this every time you see an angle. You want to say a name for one of them and everybody know what you're talking about. Why do we have names? We have names so people could talk about us. Well, not really, that they could talk about us, but that if you say, hey, I was talking about Jack Smith. Well, we all know who Jack Smith is. So that's the purpose of names. I have to tell you a little story. When I first started teaching, I was doing a lesson on naming angles. And I did the lesson. It was okay. And at the end, the principal of the school said, so why'd you do that lesson? And And by the way, it was only my like 5th day of teaching. And I go, why did I do that lesson? It was the next one in the book. He's like, wrong answer. I'm like, what's the right answer? And he said, the right answer is there's a reason we need to know how to name these so we can talk about them and that everybody knows what they are. So, because later on we're going to talk about other things, triangles, rectangles. And when I say 90-degree angle, instead of saying 90 degrees, there's another name for that. Or if I say less than 90, there's another name for that. So let's talk about those names. In your workbook, you will see the types of angles listed. One is the acute angle. Acute angle does not mean a very pretty angle. That was funny. Okay, an acute angle is an angle that's more than 0 degrees, so it has some rotation, but less than 90 degrees. And that's in your workbook, but so we'll just name this one. This is the acute angle, because it's 0 degrees would be no rotation. See, handy dandy rulers. 0 degrees would be I'm not moving at all, no rotation, but less than 90 is not as far as this, but anywhere up to that. Okay, so that's an acute angle. 90 degrees, I'm sure you know that one. That is your right angle. I'm sure you've heard that before. 180 degrees, we've talked about that already. That is your straight angle. And then more than 90, but less than 180, okay? I'll put that in parentheses. That's in your workbook, but just so you know, but less than 180 degrees, so not quite the straight line, that's your obtuse angle. So these are the names for the different angles, and you need to be aware of those names. All right, so let's take a look at this problem. You want to find the measure of angle. That's the other symbol. Angle DBC. Let's take a look at where DBC is. Okay, angle DBC. So that's this angle right here. Okay, it's this rotation. Now notice this says it's 63 degrees. So this rotation is 63 degrees. The entire rotation is 90. Okay, so the whole thing is 90. So this angle plus this angle is that 90 degrees. We already know this angle is 63 degrees. We want this angle right here. Well, if the whole angle is 90, that tells me that that angle we're missing, angle DBC, is 90 minus 63. Which is 27 degrees. So the measure of angle DBC is 27 degrees, okay? Well, I want to talk about this. Okay, this is 27 degrees. These are two angles that add up to 90 degrees. They actually have a special name. If you take a look in your workbook, it says that two angles that add up to 90 degrees are called complementary angles. And I remember complementary by corner. See this little corner for 90 degrees? That's kind of cool. Okay, so complementary angles, I'm not going to write the definition down because it's in your workbook. Okay, complementary angles are two angles whose sum is 90 degrees. Of course, then we also have a name for two angles who add up to 180 degrees, and that is supplementary. And I remember complementary, remember, by corner, because the corner tells me it's 90 degrees, C in complementary, C in corner. I remember supplementary by straight, because remember a straight angle is a straight line 180 degrees, and supplementary has to be two angles that add up to 180 degrees. Notice both of them are two angles, only two angles that add up to either 90 to be complementary or supplementary, two angles that add up to be 180. By the way, they don't have to be in the same diagram. Okay, I just did this because I thought it was a cool problem. But you could actually have two angles that are in different diagrams. So for instance, let me give you an example. You can have an you saw that, right? I dropped the eraser. That's okay, don't worry about it. Okay, obviously this is an obtuse angle more than 90 degrees. So let's say I don't have a protractor, so I'm just going to take a whack guess at this. Let's say 110 degrees, and let's say I wanted supplement. Well, there's only one angle there, but I can still find its supplement by finding the angle that adds up to 180. Okay, so I know I need a 70-degree angle to do that. So I know I need to have another angle that's 70 degrees. And I'm not certain that's 70, but I know it's less than 90. So here are two supplementary angles. And remember, it's two angles that add up to 180 degrees. Well, let's take a look at the next problem. All right, looking at this next problem, here we have an angle at 73 degrees. We want its supplement. and here we have an angle that's 45 degrees. We want its complement. So take a second to do those in your workbook, and then come back to the video when you're ready. Okay, what we have to remember to do this problem is that supplementary angles add up to 180 degrees. So all we have to do is take 180, subtract 73. I think I could do this in my head. It's 450. No, I'm only kidding. Okay, so it's 107 degrees. So that is the angle that's supplementary to 73 degrees. Okay, they are supplements of each other. Okay, and here, the complement of a 45-degree angle. Well, remember that complementary angles have to add up to 90 degrees. So I go 90 minus 45, and I get another 45-degree angle. So 45 degrees is the complement of a 45-degree angle. And that's it. That's supplements, complements, and angles. So next time we meet for lesson 2, we're going to talk about triangles.